Okay, so in this problem, what we have is this continuous random variable x has probability density function f of x, where f of x is defined over two ranges. We have x over 3 for the range 0 less than or equal to x less than or equal to 2, and minus 2x over 3 plus 2 over the range 2 less than or equal to x less than or equal to 3. And of course it's 0 otherwise. So what we're going to do, just like in the last example, we are going to deal with this probability density function over its two different ranges, and by doing so we can generate the two different cumulative density functions over those ranges. So we'll start off just by integrating over the range 0 to t the function x over 3 with respect to x. So we're going to integrate that function. When I integrate x, I'm going to get x squared. So when I divide a third of x by 2, I get a sixth of x. So we get x squared over 6 integrated or evaluated on the range of 0 to t. Now, when I substitute t in, we get t squared over 6 minus 0 squared over 6. So this one works out quite nicely for us, because what happens is 0 squared over 6 is 0. So what we end up with is the fact that for the range 0 less than or equal to x less than or equal to 2, f of x is equal to simply t squared over 6. Okay, so that's the first part of our problem done. Now what we need to do is we need to do exactly the same idea over the range with a function over the range 2 less than or equal to x less than or equal to 3 with a function minus 2x over 3 plus 2. The only thing that's slight difference here is that we need to take into account what probability has been accumulated over this first range here. Okay, now what I mean by this is if actually we evaluate the probability of x being less than or equal to 2 by putting 2 into the cumulative distribution function, what we're going to find is we get 2 squared over 6, which will of course be 4 over 6, and it then simplifies to 2/3. Now what that means is, over this part of the function here, from 0 less than or equal to x less than or equal to 2, 2/3 of our probability out of the 1 has been accumulated. Now we have to take that into account when we now actually find a cumulative distribution function for the range 2 over 2 less than or equal to x less than or equal to 3. So our function at that point, f of x, will actually be equal to f of 2, because we're going to take that probability all the way up to 2, and then we're going to add it to the value we get when we integrate over the range 0 to t, just like we've done before, minus 2x over 3 plus 2, integrated with respect to x. So what we're going to get, f of 2 we've just evaluated as 2/3, so we're going to get 2/3 plus the expression that we get when we integrate our function now. So when I integrate x, it goes to x squared. When I divide that minus 2 by the new 2, it will just simply cancel out the 2, so I get minus x squared over 3, and then of course 2 as a constant just integrates to 2x, and so we're going to then evaluate that over the range 0 to t. So now working through this, we've got the 2/3 which we accumulated over that initial range, that first probability density function, plus we're going to have minus t squared over 3 plus 2t. So that's substituting the t into our function. Now we're going to subtract the value we get when we put in, made a little bit of a mistake here. Let's just get the rubber. This of course isn't 0, apologies. This should be the value, because I'm integrating over the range 2 to 3, so that should be a 2, and of course this one here, so apologies, silly mistake if that confused you. That is of course my error. It should be over the range starts from 2, so just make sure please that you do acknowledge that that is a 2 and that is a 2, so apologies for that. So when I substitute in now my 2, I get minus 2 squared. Now be careful on this one because of where the bracket is. This is actually square the x value and then subtract it. It's not the negative x value squared. This is over 3 plus 2 lots of 2. So close my double bracket and there's my square bracket. Okay, so let's take it down onto this new line here. So I'm going to get 2/3. We're going to get minus t squared over 3 plus 2t, take away. So I'm going to get minus 4/3 plus 4. 4 of course is 12/3. So minus 4/3 plus 12/3 will give us 8/3. So we're going to have here minus 8/3. And at this point we can just tidy things up. And so what I'm going to get is, I'll put the 2t at the front just so that I don't start with a negative. 2t. I'll take away the t squared over 3. And then of course just deal with this. 2/3, take away 8/3 is 6/3. So it just tidies up there at the very end to give us minus 2. And so for the range, making sure I get the range right this time, 2 less than or equal to x less than or equal to 3, f of x is defined as 2t minus t squared over 3 minus 2, and the problem is solved. So hopefully you've seen in this video that just like when we had to deal with finding k for a probability density function when it's defined over 2 ranges, we're going through exactly the same process. It's just that we're having to work with these 2 different ranges. So the difference here is I've integrated between 0 and t for this initial function, and it's defined my probability. It's given me a probability density function just the same as we did with one function. But you notice when I actually put in the end of that range, instead of it being equal to 1, excuse me, it is actually equal to 2/3. That's because we haven't covered the entire range that its probability density function is defined for. So then when we integrate for the second probability density function over the range 2 to t, what we have to make sure is we take into account is that we've already integrated over a certain part of the function and accumulated a probability of 2/3. So we just put that little adjuster in here at the beginning, the f of 2, so that that can be accounted for when we work through the probability density function. Okay, and you can see actually it's very similar to what we've done before. The main difference is being for that first range, when we integrate over the maximum value for that first range, it won't be equal to 1 because there is more of this function to be integrated over. And then the other change being when we actually integrate over the second half of the function or the second part of the function, we have to acknowledge the probability accumulated from the first part of the function. And this can then extend to if f of x, the probability density function, is defined over 3 functions or 4 functions. But you don't have to worry about that. You're not going to necessarily have to deal with that. Okay, I hope that made sense.